Welcome to this explainer. If you've ever found yourself feeling completely wired and tired, just staring at the ceiling at 3 a.m., you already know firsthand that sleep isn't just some simple on and off switch. It is a highly complex, beautifully orchestrated biological framework. So today, we're going to explore the deep molecular, evolutionary, and neurological mechanisms of human rest, and we'll discover how we can actually take conscious control of our own nervous system. Let's dive right in.
It all starts with a seriously baffling question. Why in the world does the human brain actively sabotage its own rest? Well, to solve the mystery of modern insomnia, we really have to understand the evolutionary sleep-stress trap. You see, our brains interpret a late-night worry exactly like a physical predator attack. Deep down in your ancient circuitry, your biology literally does not know the difference between a looming financial deadline and a looming tiger.
Section 1. The evolutionary sleep-stress trap. When we experience stress, our evolutionary wiring essentially forces our brain to lighten our sleep stages. It actively increases these tiny micro-awakenings as a compensatory mechanism. Think about it, your brain is prioritizing high-alert vigilance, deciding that, based on your stress levels, it is simply not safe to be unconscious right now.
But here is where that evolutionary trap completely snaps shut. This survival mechanism frequently spirals into what we call clinical hyperarousal. Now, this isn't just feeling a little bit stressed. It's a severe, persistent activation across your cognitive, emotional, neuroendocrine, and autonomic domains. Your nervous system becomes so persistently wired that your heightened sensory processing actually blurs the line between sleeping and waking. It causes something called sleep state misperception, which means you actually feel wide awake even when you are medically, technically asleep.
Section 2. Anatomy of neuroendocrine hyperarousal.
If we look at this microscopically, we see a tale of two totally different stress systems. The rapid-acting SAM axis handles your immediate fight-or-flight reactions, like that sudden adrenaline spike you get when you drop a glass. But it's the slower HPA axis that sustains prolonged, grinding stress. And a chronically activated HPA axis floods your system with evening cortisol. This completely shatters your healthy sleep architecture and prevents your brain from ever dropping into that deeply restorative slow-wave rest.
And the fallout from this? It's entirely systemic. Sleep fragmentation triggers a brutal cellular vicious cycle. The body actually begins to release pro-inflammatory cytokines, things like interleukin-6 and TNF-alpha. And these aren't just byproducts of having a bad night of sleep. They act as signaling molecules that loop right back up to the brain, reactivate the HPA axis, and further sabotage your rest. So your body's own immune response begins fueling the insomnia.
Section 3. Melatonin, thermoregulation, and immunity.
So how exactly do we break that inflammatory loop? Well, the brain relies on a highly integrated circadian mechanism. We so often think of melatonin simply as a sleep supplement you buy at the store, but naturally, it acts on specific MT1 and MT2 receptors to actively attenuate wake-promoting signals. It is a profound biological cue that executes a whole circadian thermoregulatory cascade, fundamentally changing how your body handles heat.
This creates one of the coolest, and I mean literally coolest, mechanisms in human biology, the distal proximal gradient. Through MT2-mediated vasodilation, melatonin redirects blood flow away from your core and pushes it out to your extremities. Your hands and feet warm up to aggressively dissipate heat like little radiators, which rapidly drops your core body temperature. That specific temperature drop is a mandatory physiological requirement to initiate sleep, and as it falls, parasympathetic dominance finally rises.
Section 4. The vagus nerve superpower.
The vagus nerve is the longest cranial nerve in the human body. You can kind of think of it as a massive information superhighway connecting your brainstem straight down to your gut, your heart, and your lungs. By measuring what's known as vagal tone through heart rate variability, we can actually quantify your nervous system's flexibility. Having a high vagal tone means your body has the agility to downshift rapidly from fight or flight into rest and digest, essentially putting the brakes on that systemic inflammation we were just talking about.
And honestly, the absolute most exciting revelation in this explainer is that unlike automatic functions like digestion, we can consciously control our vagal activity. As Dr. Vernon Williams points out, using targeted behavioral levers like deep breathing, meditation, or even just experiencing awe sends a mechanical signal right up the vagus nerve that physically changes our brain state.
Section 5. Respiration and hacking the baroreflex.
We can actually get remarkably specific with our respiration to physically pull that parasympathetic lever. Take box breathing, for instance. Inhaling, holding, exhaling, and holding for 4 seconds each. This beautifully balances the nervous system by stabilizing intrathoracic pressure and engaging the barrel reflex. But if you want to aggressively prepare for sleep, the 4-7-8 method uses prolonged exhalation to activate the cardiac vagal brake. The breath hold causes a mild CO2 accumulation, and that actually increases the vagus nerve sensitivity, instantly lowering your heart rate and blood pressure. To prove just how systemic this effect really is, researchers took 16 healthy individuals and had them practice this exact kind of relaxed, deep breathing. And the results were completely astounding. Not only did their sleep readiness improve, but these participants experienced significantly less tension, lower depression scores, and actively felt less physical pain than a control group. That is the sheer, undeniable power of consciously forcing a parasympathetic shift.
Section 6. Top-down cognitive arousal control.
Of course, if your mind is absolutely racing, breathing alone might not be enough to break the loop. And this is exactly where top-down strategies step in to dismantle psychological arousal. Mindfulness-based therapy for insomnia utilizes practical tools like scheduled worry time. By actively setting aside time to worry during the afternoon, we validate the brain's evolutionary need to process threats. You're basically telling your survival circuitry that the threat has already been handled, which prevents that cognitive arousal from spiking the second your head hits the pillow.
Understanding these first principles totally changes the entire paradigm of how we view insomnia. Sleep is not just something you passively catch. It's a highly guarded physiological state, and you must actively signal to your body that it is safe enough to drop its defenses. We've traced the inflammatory loops, the HPA axis, core body temperature, and those powerful vagal pathways. So the only question left for you is, which biological lever are you going to pull tonight to signal to your brain that it is finally safe to rest?